All right, so today's lesson is on segment relationships in circles. Relationships in circles. We are on page 43. Today is not the 21st. Today is the 23rd. Okay, so we're going to go through some definitions before we actually look at problems. Can someone remind me what a chord is? We need to know the definition of a chord. Still?
Line that has two endpoints touching the circle.
Okay, so I'm going to be a little more specific. It's a segment that has an endpoint on one side of the circle and the other endpoint on the other side of the circle. So remember yesterday when we drew, or when you drew, this, here's a chord. Is there another chord in my picture? The diameter, right? So you talked about that a diameter is a chord, but a chord is not necessarily a diameter. Yes? Okay. So we have something called the chord product theorem. Okay, so we're going to deal with two chords, and what does product mean? Multiply, right? Multiplication. So the chord product theorem. So let's start by drawing a circle. And we're going to draw chord CD and draw chord AB, and they are going to intersect at point E. So the chord product theorem says AE times BE equals CE times DE. So let's look at what each of those things are. So AE times BE equals CE times DE. Okay, so here is AE, right? That's a piece of one of the chords. And BE is the other piece. Do you see that? So we're going to multiply the two pieces of the chord together. And that's equal to CE, which is a piece of the other chord, times DE, which is the piece of that second chord as well. So it's piece times piece equals piece times piece. Okay, so this is what I will give you on your test. This exact thing right here. You just have to be able to plug in the information and solve. Are we okay with that definition? Yeah? Okay. I need to give you a definition because I don't think we've talked about what a secant is. Have we? Does that name sound familiar? No? Okay. So we've talked about chords and tangents. So a secant is any line that intersects a circle. Thank you. At exactly 2 points. So here's where we actually have a line. Okay. It intersects the circle at exactly 2 points. A tangent intersects the circle at how many points? 1. Okay, so the secant's going to intersect it at 2 points. Now, a chord intersects it at 2 points, but a chord stays with in the circle. A secant will extend outside the circle. Maybe not in both directions, but it will go past the circle, okay? If it's just inside the circle, then we're talking about a chord. But if it extends outside the circle, we're talking about a secant. Okay? So the next definition is the secant product theorem. Yeah, no, going off. Okay. All right, so we're going to draw a circle. And I'm going to draw secant AE. And it's going to cross at B as well. So that's a secant because it crosses the circle twice, but then it extends out past the circle. Okay? And then I'm also going to include secant CE that will also cross at point D. Okay, so this theorem says BE times AE equals DE times CE. BE, you should notice, is this outside piece. Right? So BE is my outside piece. And what's AE? It's this whole thing. Okay, so you're going to do that outside piece times the whole piece. So this is the whole, I'll call it the whole line. Okay, so it's the outside piece times the whole line. Is it the same on this side? Right? It's the outside piece times the whole line. We still okay? Okay, we have one more. And again, I'm giving you these so you don't have to have them memorized. You just have to be able to identify which ones they are. The last one is the secant tangent product theorem. So secant tangent product theorem. What did I just draw? A secant, right? It touches the circle twice and it extends out past the circle. So that's my secant. What's that? A tangent, because it hits the circle once. Okay? So this theorem says BE times AE equals DE squared. BE times AE equals DE squared. So what kind of pieces are those? What is BE? The outside piece. Okay, so it's the outside piece times what? The whole thing. So the outside piece times the whole line equals the tangent. Good. Equals the tangent squared. Okay, so if you have, I'm going to try to pull all this together. If you have all three of these in front of you on the test, okay, well that didn't do any good. If you have all three of those in front of you on a test, you should be able to identify what type of problem you're working with, right? And then you can look at it and plug in what you need to plug in. Okay, so let's do an example. Let me fix this again. So we are going to solve for x. Which one of my three am I going to use? The chord. Everyone see that there's two chords? Okay, chord says we take the piece times the piece, and that's on the same chord. So let's look at this chord first. Okay, so the one piece is 9. I probably should have given, oh, I don't have a middle letter. One piece is 9. The other piece is 8. Equals. One piece is 6. The other piece is x. Can you solve something like that? Yeah? 9 times 8, 72, equals 6x. And if you divide by 6, you get x equals 12. Cool? All right, let's try another one. I need to switch papers. Hold on. So we're going to be given that AD equals 12, so that might be helpful for us. Let's see. So which one am I using with this? Chord. Okay. So I need all the pieces of the chord. Do I have all of that information? No? What am I missing? Whatever that, I guess we can call this middle point E, right? We're missing ED. Is there any way to find ED so I can set up my equation? So the whole piece of AD is 12. I know AE is 3, so 12 minus 3 is 9. Okay, now I have all my pieces. Now I can set up my equation. Okay, so if I look at AD, it's going to be 3 times 9 equals 14x. 3 times 9 is 27 over 14x. Does 14 go into 27 evenly? So you're just going to leave it as a fraction. If you can reduce, you should. If you absolutely have to plug it into your calculator and give me a decimal, that's fine too. This answer is 1.93, but I would prefer for it to stay as a fraction. Okay, don't do the extra work if you don't need to. All right, I'm going to give you one and I want you to identify which formula you're using and see if you can set it up. Okay? So, let's see. So we're going to solve for x. And we're going to find the lengths. Okay, so all I want you to do, I don't need to solve it, but I want you to identify which one of those three theorems you're going to use, and I want you to set up the equation. So let's see if we can set up the equation correctly. So identify which one of the three theorems you're going to use. I should probably give you the rest of the letters. And then set up the equation. Did we choose? Secant, secant. Everyone agree with that? Does someone have an equation that they think is correct? David?
5 times x times 5 equals 6 times 36.
You're on the right track. Not quite there. Chris?
5 times 5 plus x equals 6 times 12.
Okay. So the secant product theorem says the outside piece times the whole thing equals the outside piece times the whole thing, right? So let's start with this secant. So the outside piece is 5. What's the length of the whole thing? 5 plus x plus 5, doesn't matter how you write that because it's plus. Okay, so the outside and then the whole thing equals, what's the outside? 6 times the whole thing,
12.
which is 12. Are we okay with that equation? And then what would I do to solve? Distribute, okay? So 25 plus 5x equals 72. I'm going to subtract 25. So 5x equals 47 over, whoops, well, apparently I did 2 steps in one. 5x equals 47, then divide by 5. Thank you. So I'm getting x equals 47 fifths, or if I make it a decimal, it's going to be 9.4. Now, for this problem, because it also asks you to find the lengths, it might be best to do it as a decimal unless you love adding fractions. Okay? Which I know most of you just adore adding fractions together, so we're real tired this morning. Okay, so here's my value of x. I need to find the length of AC, and I need to find the length of AE. So if x is 9.4, what is the length of AC? 14.4. And AE, we already know, right? 6 plus 6 is 12. Cool? Okay, I'm going to give you one to do complete. Like, I want you to figure it out, set it up, and solve. Yeah? All right, let's see. So same directions. So set this up and solve. Someone new. Who helped me earlier? Someone who hasn't helped me. Oh, wants to talk to me this morning. Nobody? Oh, come on. Christian.
Well, the theorem is secant plus here.
Okay.
And the setup is 5 times 10.4 equals 4 times 4 plus x.
Did everybody get that? Oh, you can't see that because I didn't unfreeze. 1 second. Did you get that? Yeah? Okay, so the outside piece times the whole thing equals the outside piece times the whole thing. When you multiply 5 times 10.4, what'd you get, Christian?
52.
52 equals 16 plus 4x. If you subtract 16 from both sides, you get 36 equals 4x, and you end up with x equals 9. So we already know RP is 10.4, right? What is the value of TP? 13? Not too bad? No? Okay. We have 2 more examples and then we're done. So we're going to solve for x. Do you think you can set it up or do you want me to do it with you? Someone asked to talk to me this morning. No? We're still going to just sit in silence? Okay. So does that mean you can do it on your own? Yeah? Okay. Okay. What did we use for this one? Secant tangent. Okay, someone new help me set this one up. David?
2 times x plus 2 equals 5.
Perfect. Okay, so it's the outside piece times the whole thing equals the tangent squared. So this is 2x plus 4 equals 25. 2x equals 21. You have 21 over 2, or you can look at it as 10.5. All right, one last one. There we go. Is this the equation everybody got? The outside piece times the whole thing equals the tangent squared. And then you have x squared plus 6x equals 100. What did you do from there?
Square.
Nothing?
Square root nothing.
You cannot square root that. What can we maybe do? Subtract the 100. Because then this is now a quadratic equation. How do I solve for x if I have a quadratic equation? We can factor. Okay, so let's think about this for a second. So factoring, we can use our t-chart, right? So what two numbers multiply to negative 100 and add to 6? I see our brains thinking. Give me two, let's throw out two numbers. 10 and 10. Okay, is there any way to add those to 6? No. 20 and 5. Is there any way to add those to 6? Okay, so if factoring doesn't work, which it doesn't look like it's going to here, what's our next option? If we have a quadratic equation, the quadratic formula. Who remembers the quadratic formula?
Can I try?
You can try.
Plus minus negative b, no, plus minus b equals, x equals plus minus b square root b minus 4ac all divided by 2.
You have all the right letters in there. It's close.
It's-
Yadin.
Negative b plus or minus the square root of a squared plus b squared.
Minus 4x.
I'll just finish that one. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what is my a? What is a? 1. What is b? And c is negative 100. Okay, so let's go through and plug this in. So x equals negative b, so that's negative 6, plus or minus the square root, b squared, so 6 squared is 36, minus 4 times a times
Plus 400.
c all over 2 times a. Some of you probably did a little more in your head, and that's okay. So I have negative 6 plus or minus the square root. This is 36 plus 400, right? So 436 all over 2. Is 436 a perfect square? No? Okay, so what happens when it's not a perfect square? We have to do the factor tree. So we know that what goes into that? Other than 2, I'd like to use a bigger number. Just 4? Let's do 4. 4 and 109. So that's 2 and 2. Does 109 break down? No? Okay. So we have negative 6 plus or minus 2 square root of 109 over 2. Am I allowed to do anything else?
Yeah,
Yeah, what am I allowed to do?
reduced by 2.
Reduce by 2. But remember, if you're going to reduce by 2, it has to be to all the terms. So 2 goes into itself once, 2 goes into itself once, 2 goes into 6 3 times. So our final answer is x equals negative 3 plus or minus the square root of 109. There will not be a lot of problems like this. Should you know how to do it? Yes. Have we used the quadratic formula before? Yes. So just because it was a first semester topic doesn't mean that we can't use it second semester. Okay? Any questions? All right.